We're back at it, and we are going to do some more Swift stuff, in particular, TOML stuff. I barely had my first coffee, so we'll see how this goes. All right, let's look at what we should do today. I think there's a good chance we'll finish everything we want for a minimal viable decoder. That would be quite exciting. And if time permits, we'll do some release stuff as well. I'm not sure how long this all take. I'm going to see Captain Marvel tonight, so there's a hard deadline there. Hopefully, things won't take that long. So yeah, these are some things that since yesterday I think we need to do at least. Let's just go through them. Since we're supporting foundation, so it's reasonable to expect people want like images or something, their TOML file as a string. So in that case, they should specify they want a data and associated strategy. I can't think of any other strategy other than base 64. But maybe we can encode the string as a UTF-8 string if they want. Okay, so then you can say, I want, hey decoder, give me a data. Then you can get a foundation data type. And then there's a bunch of more date stuff we could do. Yesterday we added support for decoding into a date and date component for the TOML defined first class date values. So, but there's more ways you can get a date, right? You can say, I want to, I'm not sure I want to support this. Like you can say, I want to convert a string to my own date, but why would you if you're using TOML? So that probably won't be supported. But maybe a legit strategy to converting it is, I want to say convert a timestamp, like epoch timestamp. Then in the foundation world, there are two epochs, right? There's Unix epochs and the core foundation epochs from 2001. So you can take an integer or float and technically and from milliseconds and seconds. So there's a number of things, ways you can get a date from those kind of data. Although I'm kind of inclined to not support that at all. Because again, like, why would you do that, right? The only way I can think of is like if you're using TOML as some kind of transport protocol, which I don't really recommend, but if people want, they should be able to. The other way is you're getting a timestamp from somewhere and you just want to paste it in your TOML config, which I would say that's very unfortunate for you, but if you, I can see that being a legitimate use case. So in those cases, there's yet another dimension in this. So we have two epochs to pick from. We have second versus milliseconds, and then the third dimension is you could get it from number of seconds as an integer, or number of unit. In this case, can be milliseconds, seconds, as an integer or float. Time interval in foundation is a float, but I think it's a stretch to support both integer and float in this case, if we were to support it at all. Okay. Yeah, so that's that. Let me jog it down. Dimensions. So we have Unix. We have okay, so that's 2 to the 8th. So the maximalist position here is to support 8 strategies. Wow. In addition to this, all the support we added yesterday, just for dates. I think this is a stretch. The more I think about it, the more I'm inclined to call it like you can get your date component, and you have already a strategy to say I want a strict way to only get the native. We'll get into it, but there's already a strategy involved in there. Okay, so the key strategy is a no-brainer, right? In this case, nothing really changes among like JSON keys and TOML keys. Maybe a wrinkle in here is TOML keys support all UTF-8 strings. I'm not clear on what JSON supports, but it's common to convert your snake case into your camel case. Provide option to do whatever you want with the string. So this is a no-brainer. We need to add this, and as I noted earlier, we really, by add, I mean steal this, right? And then there's some improvement for errors. I think this can be filed as a bug, but we do have some horrendous error, string as error throwing right now. So that needs to be dealt with before I can make this available to anyone else. Yeah. So why don't we start with data? Because data seems unambiguous. And then we will move on to the key decoding strategy, because it's also very clear what we need to do. And then we'll probably get very tired, and then we'll say F it, use the proper string in your TOML. Use the proper date in your TOML. Hopefully. We'll put it even lower than this. Yeah, because like if we really are after like a minimal viable thing, I think we already have a viable solution for dates. Yeah, like the more I think about this, the less I want to do it. Okay. Okay. So let's briefly tour what we have so far. So here are the tests that can demonstrate what we do support today. Oops, sorry about that. So you can have your codables. In this case, There's the first codable, the second codable that uses the first codable. And here's your TOML file. In this particular example, we're using an array of tables. What that means is, imagine JSON, you have a JSON array, and then each object in the JSON array is a dictionary, and inside the dictionary is your normal object representation. In this case, is some kind of a player. You have a player ID and their health, string versus int. And all you need to do here is, hey, TOML decoder, give me this team object from that TOML data. We also, by the way, support both data and string, which makes sense because most of the time you have strings, right? And your result should be a team object. Similarly, you can, this is just typical, expected patterns for using decoders from Swift. In this case, where we implement a custom decoder for the player object, and we specify the key, we explicitly ask for the container with keys, and basically translating to, I want to parse things out of this dictionary. And then we proceed to decode the individual values from the dictionary and assign them to our properties. And the end result is your player gets decoded as expected. I threw in a float here just because it's a test. Similar, again, you can do the custom decoding with your on-keyed container, quote unquote. On-keyed container, you can think of them as arrays. Again, these are not specific to the TOML decoder. It's really just your typical Swift decoder, how it works. So in this case, you get to see whether your array is finished. It's a stateful object. And then you can get individual values from your array. And again, this goes back to the first example, and you should be able to get your team this way as well. We also have a integer decoding strategy test where by default, we allow you to take int 64, int 8, unsigned int, all kinds of ints built in the integers. You can expect any of these values to be decoded from your TOML integer. But the TOML integer actually is explicitly defined as a 64-bit integer. So sometimes those will fail. But if you want even stricter control, you can go ahead and say, my decoding strategy is going to be strict. And what that do is it will cause a decoding like this to be an error. Unfortunately, it's a runtime error. But so in this case, our health is an int versus int 64. And in strict mode, that's error. So this test verifies that behavior. And then these new ones we added yesterday are for the dates. So internally, TOML decoder calls another library called TOML deserializer. TOML deserializer leverages another library called nettime, which provides a bunch of simple in-memory representation of RFC 3339 dates. And these dates, they have you as a part of the decoder, you can say, hey, give me that date from that library. Because it's native, so it's the most efficient way to get it. Even though I think in case of decoder, especially for TOML decoder, where I expect you to use it in some kind of config file, this sort of efficiency is not that important. But I eventually want to get to a benchmark for TOML deserializer, where we do keep track of what's going on inside the library and optimize it to the best, do the best we can. But essentially, these are examples of how you would construct the native values from nettime library. And as you can see, it has some kind of it has checks for, it's a failable initializer. So if you put in valid dates or time, it will fail you. And you just go ahead and create a bunch of these expected values and decode your object from your TOML. And then it should become, the fields perspective should each have these correct constant values. And that's this test. And again, very, very similar. We decode here a date. This is a foundation date. So you specify your full timestamp with, with time zone specified. And then you decode it, and you should get your object as expected. So foundation date is supported. And again, in TOML, you have the ability, especially in the 0.5 specification, you have the ability to specify a time or a date and a time without the time zone. In that case, is really just like something on your calendar, on your Gregorian calendar explicitly. So it's just some abstract concept of a mark in your calendar instead of an actual concrete moment in time. In those cases, the way it's supported through foundation is you get to use your date components. So literally, you have a year, month, date, then you can get that from your TOML via a date component. So you get your year, month, date by doing this. And if you try to do that as a date, currently it will throw an error because that's a misuse of date. And yeah, these following three tests are basically the same, except this one's for date, this one's for time, and this one's for date time, as I mentioned earlier. And the last one is a start where you can say the decoding strategy is strict. In that case, foundation disabled. Support the, well, I wouldn't say foundation disabled, but if you try to get a date or a date component from foundation, it will throw an error. I'm a little hesitant to say this is what we want, but it is what we have so far. It's a little too, yeah, because I imagine most people want to use foundation. But in the case that you want to prevent others to use foundation, you can do this. Yeah. Anyways, so that's what we have so far. And yeah, let's get back to supporting data today. All right. Start with the test. Data decoding. So here's the question. Do we want data, the default strategy, do we want it to be a UTF-8 string data? Or do we want it to be base 64 data? Because TOML doesn't have the concept of data. So we need to basically assume if you ask for data, you're expecting the value to be string. I am going to say base 64 is kind of, I feel like base 64 is less common, but you're asking for data, and I mean, who the heck uses put data in TOML anyways, right? Like a binary data. I mean, So it is a kind of a weird thing. So let's work on this first. So we'll have a data thingy. Let's all right. So you know what? Let's use a literal string here. Also, please don't call your variable data. That's terrible. Let's use image. How about body? Some kind of a network payload or something. And again, in TOML, you can't represent data in any good way, so you have to, live with strings. So we're just gonna copy all this, right? There's the payload, and this should equal I guess yeah, we'll go with base64 not being the default strategy. So you by default will get a UTF-8 encoded as data. Again, why would anyone want this? I have no idea. But yeah, base64 is a legit use case, like images and stuff. Maybe the default strategy should be maybe the default strategy should be base64. Yeah. Yeah. Another piece of this project that still needs to be done is documentation. There's so much decision being made during development, and it's gonna be there will be a lot of confusion between like what's in TOML, what is in Decoder, what's in Foundation, what's in JSON, not in TOML, why things are in JSON Decoder that you can't find in TOML, things and all kinds of things like that. Okay, so right now this won't even compile, which is okay. Perfect. I have no idea if this is a valid base64 value. I think it is because it says 64. They're all 60-bit. I mean, hex digits. So right. Foundation data with UTF in. Okay, neither of this will compile because data is not supported, and we don't even have the strategies defined, which is great because now we know what to do next. We're gonna define the strategy, right? So public enum data decoding strategy. We have UTF-8 and we have base64. And we add a property, change this letter, give it our default. Default would be base64, executive decision. And then we'll go to the infamous unbox method. So this is where we kind of dispatch our support for non-standard library types. You see, well, I said that too soon, but and string and bool, I guess. I'm fairly confident that I will pick one of the formatters out there and apply it to all my open source projects. So not overly concerned about the going up column limit thingy. Okay, I think it's fair to say if you want a data, then you're gonna go last, meaning we'll do a bunch of more casting before we do it for you because it's the fringe case. Data. Okay, now let's write a function for data. Yeah, and I'm kind of unclear on what I have to distinguish between the two cases. So uh-oh. Did I miss something? Aha, you need to also define here. Also, this needs to be data decoding strategy. Data. Okay. My delivery might be coming soon, so Here we go. Data decode, and then we can say dot the right type. Oh, data. There we go. I'm still getting used to the auto-completing Vim. Like, there's a lot of freezing that I really don't like, but the autocomplete is pretty awesome with SourceKit LSP. Okay, so we do two things. Our input would be a string. So the first thing we need to do is check that. Come on. Although if your input is not a string, can we also encode it into a data? That's interesting, right? If you have a number, even a dictionary, dictionary into data, number into data. Yeah, there's some more. We ask the internet. NS number to data. Is this a thing? Of course, because data is just a series of bytes. So anything can be data, right? How about an ASCII archiver? Do I want to touch this? Let's look at what's supported in JSON decoder. Encoder. Deferred data, base 64, and custom. Deferred data. So I guess JSON deserialization, JSON serialization straight up give you something data from. Deferred data. Okay, so data conforms to things. Data conforms to decoder, and then it will do a bunch of things. Okay. Base 64, it's like if it's string, first of all, is it error? Oh, wait. It's checking, it's making sure it's a string. Okay. And it's fillable, then you throw this. I'm gonna straight up steal this block. And custom, you just call this. All right. Yeah, I need to add custom option, obviously. Maybe all I want to support is what is even this? What is this? How does this work? Data from decoder. What? Can I visor data? There's no documentation. Oh boy, I need to make this into a data. Okay. Okay, so we got an error. That's not bad. Expected to decode data, but found a number instead. Uh-huh. Makes sense. Encountered data is not a valid base 64. So for some reason, data here is all right. Swift JSON decode JSON encoder base 64. Let's read some literature. How can I encode a string to base 64? That's not what I want. Encoding, decoding, serialization in Swift 4. Sorry. Base 64. Not in here. How to encode dictionary into JSON. Why not use JSON serializer? Base 64. Nothing. Oh, I've seen this one before. This is actually a pretty good article, but it's talking about how encoder works, and we already know how that works because we just wrote one. So my conclusion from this is maybe the right thing to do is to not support deferred data. Let me look at one more thing. The default here is base 64. Okay. Wait, was I looking at the wrong thing? Defer the data. Okay. No, I wasn't looking at the wrong thing. Defer the data. So data has a thing. Okay. I see. My test was wrong. I assumed the option is this guy. So this won't work because it's not a valid base 64. Data strategy is deferred to data. And what will we get? Expect to decode array of any, but found a string or data instead. Array of any. It's getting more and more intriguing. Yeah, I don't understand. Maybe for now I'll skip it. Yeah, that's the best thing to do. Like, why trying to build something you don't understand is just exercising futile. So instead of should I support UTF-8 data? Why would anyone want that? Yeah, no. All right, first of all, the first thing we need to do is pick the right default, which is base64. We did, okay. Then for decoding strategy, we're gonna take this out and we're gonna use the custom thingy. And what does it do? It takes a decoder, right? And returns data or something. And it throws. Let's steal this guy. Yeah. Decoder returns the data. Okay. We will not support. Oh, this is encoding. Encoding data encode to self storage. Blah blah. Okay. Nothing interesting here. All right. So essentially, what we want to just steal this whole cell. And we don't have this option, so that's out of the picture. So for base64, we take the string, cast it as a string, and error out, and we create the data from base64 encoded initializer. And if that fails, we'll report an error, and then we return the data. Otherwise, we call the closure. All right. And see what compiler error we get. Unbox. It's oh, great. Data, self.data decoding strategy. That's error number 1. Error number 2. Warning, this is unused because I didn't return it. Pretty sure I need to call try here. Let's build again. Wait, did I not save? Now we built. We have built our thingy. 10 of the test cases out of date because we won't have this anymore. So we will have custom yeah, how would I even use this, right? Should I say like custom data in decoding strategy? What's the interface like? As this, you will get, you will have to configure the option to take your decoder and return a data. And when you get called, you actually receives the field value of DEF. Okay, let's try that. So decoder dot data decoding strat custom. Our input is the decoder. And our task is to create a data from a decoder. And in this case, we know string. You get a string from decoder being decoder dot single value something something. Really handy right now. So maybe we should do that thingy. My food is here, so I'll have to go and answer the door really quickly. Very soon. Oh, here we go. Haven't been saved here. Decoder dot single value container. And I want to make it nice. And then container should give us string dot self. Is this also throwing? And then we so yeah, it is string now. We can say data with UTF-8. And we return this guy. Okay, so that's how you would use a custom for data decoding. Yeah, I guess for testing purposes, we'll just do that. And we're missing a couple of things. Okay, so does this mean my test can compile now? Oh, player? No, not player. Payload. Equatable, that's fine. Expectation. Oh, I don't have expectation yet. Okay. Payload. The string will be ABC. The body will be DF encoded. And oh, okay. All right, food is here. Hi.
Is it done yet?
Yes.
Okay, here you are.
Thank you so much.
You're welcome.
Okay, so if this works, we will take a break. Test failed. Awesome. Oh, test failed because we're asserting that this was thrown error. Interesting. Why? No. Just dumb copy pasta error. That one succeeded. How about this one? It failed. This one is expecting big 64, and we're throwing because the data is not valid base 64, right? So base 64 encoder. Hello world encode. So that's the valid base 64. So I can say oh, I don't know. Oh, I should do this. Data is base 64 encoded hello world. Wait, what am I doing? Oh, that's the expectation. Would be the expectation. And then we'll put as the string value. So upon seeing this, and in combination with the fact that our decoding strategy is base 64, which should be the default now, we will get a body which is a data after payload is decoded, and its content should be this, which is this in base 64. There's something I'm not understanding here. So maybe base 64. Okay, I'll just take this thing. So that's actually much easier. 64 data. This is better. This is better. So this one only appears once in our test. It's going to be here, and our decoder should get it as a string. Do the same thing. And that passed. Okay, I like that. Wow, this side is nice. Where are the ads and pop-up? Okay. So far, we have added the data encoding. So data is now supported. Wait, did I just onstage that file? Okay. All right. I will take a break. I'm gonna eat some things, and I'll come back in, I don't know, 30 minutes, an hour, something like that. See ya.